everyone, welcome back to my channel Tutelage, a guide to economics. Here this is Tripona. Hope all of you are doing great. We had discussed in my last session different parts of table, bar diagram and pie diagram, etc. So today we are going to explain another some new concepts under this chapter, that is collection of data, and that's why this session is called the collection of data part 7. So if you have missed my previous sessions, please go and check my description box and my first comment where the previous video's link is already shared. So learner, let's move the new session and go to my next slide where we can see what is the today's topic for discussion. So now let's move. So we have already discussed what are the different ways to present the data diagrammatically. We know there are five types of way. The first and second have already discussed by me in my previous session. So now going to discuss the third one, that is histogram. Fourth one is frequency polygon. The fifth one is ogive. Okay. So the second concept, that is the concept of graphical representations, and third concept, that is population versus sample, and which is the one of the most important concept of statistics. So now move on the main slide and let's begin the session. So here this is a slide for definition of histogram. So learner, what do you have any idea what do you mean by a histogram? Histogram basically and one kind of diagrammatic representation of data, but when we are using the grouped frequency distribution. Okay, so those data are presented graphically in the form of rectangles in the diagram, and which is known as the histogram. So histogram is a rectangular diagram which is presented when we have grouped frequency data distribution, and here this is the graphical representation of histogram, and we measure number of students in the vertical axis and score on a final exam on the horizontal axis, and it is and we can see it is very similar to the bar diagram as look wise, and histogram helps to show the frequency distributions because we are using the grouped frequency data distributions and how often each different value in a set of data occurs. So what type of data are used in histogram? So whole data which are used in histogram, the all data are continuous variable. All data are continuous data. Okay, so both are, so bar diagram and histogram both are very similar as look wise, but they are different according to their characteristics. So now going to the next slide where we can see the diagrammatic differences between the bar diagram and the histogram. So now move on the next slide, and so here we can see some differences between histogram and bar diagram. In bar diagram we can see each and every width of bars should be same, and bars can be reordered also, and each rectangular bar indicates the comparison of the discrete variable, and we can see the bar graphs visualizes the categorical variables like A, B, C, D and so on. And now go to the next one, that is the histogram. Histogram basically visualizes the numerical continuous data, that is 5, 10, 15, 20, 25, 30 and so on, and which we can see in this diagram, and the each rectangular bars in the histogram cannot be reordered, and width of the bars need not to be same, and we can see in histogram bars touch each other and there are no space. Okay, but in the bar diagram bars cannot touch each other and there are a specific space. Clear? So I think it is clear what is the basic differences between histogram and bar diagram, but both are similar as look wise, but both are different according to their characteristics. And bar diagram, we can use the discrete data in the bar diagram, and on the other hand we can use the continuous data in the histogram. Clear? So now move on the next slide. Here, this is the fourth way of diagrammatic representations, and that is frequency polygon. So, learner, at first we have to know what do you mean by a frequency polygon. So, frequency polygon curve is basically a geometrical diagram which connects the midpoints of the top of each rectangular bar in the histogram. Clear? So, why we are using the frequency polygon for diagrammatic representation of the data? Because it is used in the presentation of data, and it helps to show the total frequency distribution through a graph which is made by connecting the lines for joining the midpoints of all rectangular bars in the histogram. Okay, so those data we are used in frequency polygon, which is continuous and quantitative data also. Clear? And frequency polygon is not only help to make sure the data is sorted out and represented, but they are going to make it easier for the pupil, for the everyone to compare and contrast all their results. Okay, so now showing the graphical representation of the frequency polygon. I think which is clear what is the frequency polygon. Frequency polygon basically a geometrical diagram which connects the midpoints of all rectangular bars in the histogram. So now move on the next slide. And here we can see the graphical representation of the frequency polygon. Okay, so we measure frequency, so that is the cumulative frequency. We measure frequency in the vertical axis, not the cumulative frequency, and bin values in the horizontal analysis. And we can see all the midpoints of each rectangular bars connects with a line. So the locus of all midpoints of each rectangular bar is known as the frequency polygon, and this is so it looks as this one. So that's why it is called, the frequency polygon is called a line graph. Okay, so now going to the next one, that is the ogive or cumulative frequency polygon. So move on the next slide. Here this is the slide for ogive. Learner, at first we have to know what do you mean by a ogive and why we are using the ogive for the diagrammatic representations. So ogive is the curve which is constructed by plotting only the cumulative frequency, not the frequency. So here we can give importance on the cumulative frequency. Okay, so not the frequency. Clear? So we know there are two types of ogive. The first one is less than, and second one is more than ogive. So now going to the next slide, and where we can discuss the what is the less than and more than ogive. So now move on the next slide. So here we can see the definition of the less than ogive and more than ogive. Okay, so now let's start. So in the less than ogive, the frequencies are added in the so frequencies are added starting from the upper limit of the class interval of the frequency distribution, and the cumulative total tends to increase, and that is the basic differences between the more than type. So more than ogive is constructed by subtracting. This is adding, and this is the subtracting method, the first and second class frequency and so on from the total frequency. So frequencies are added starting from the lower limit. So frequencies are subtracted starting from the upper limit in the more than ogive calculation, and in the less than ogive calculation the frequencies are added starting from the upper limit of the class. So that's why the cumulative total tends to increase, but in the more than ogive calculation the cumulative totals tend to decrease. I think it will be clear when we are using the example. So now move on the next slide. So here this is the slide for the example of the more than and less than ogive curves. So here we can see the four column. The first one is class interval, the second one is frequency, third one is less than cumulative frequency, and fourth one is more than cumulative frequency. We are using less than cumulative frequency in the diagrammatic representation of the less than ogive curves, and we are using the more than cumulative frequency for the diagrammatic representation of the more than ogive curves. Now let's start the calculation process. So for the first class interval 0 to 500 the frequency is 12 and the less than cumulative frequency is also 12 because there is no previous frequency. So this is the first one, so that's why 12 plus 0 that is equals to also 12. So I think it is clear how we are calculating the less than cumulative frequency. The previous frequency plus the present class frequency. Clear? So now going to the second class interval, that is 500 to 1000. So that so less than cumulative frequency for the second class, that is 30. So previous class frequency, that cumulative frequency is 12 plus the present class frequency, that is 18. That means which is equals to 30. Now going to the third one, that is the 35 is the frequency of the third class interval. So previous class less than frequency, the less than cumulative frequency of the previous class, that is for the third class interval, that is 30. So 30 plus present class frequency, that is the 35, that means 35, which is equals to 65. Clear? Why we are calculating the less than cumulative frequency? So now move on the next part, that is the more than cumulative frequency calculation. So we can see for the first class interval the more than cumulative frequency is 230, and that is the last class less than cumulative frequency. Okay. So now going to the second class, that is 500 to 1000. So 230 minus the frequency of the first class, that means 12. So which is 218. Clear? Now going to the third one. So 218 minus the frequency of the second class, that is 18. That means 200. Now going to the fourth one, 200. So present class cumulative frequency is 200 minus the frequency of the present class, that means 35. So which is equals to 165. I think which is clear. So now move on the next slide, where we can see the graphical representation of the less than and more than ogive. So now move on the next slide. Here this is the graphical representation of the less than ogive curves, and we have already calculated the less than cumulative frequency and more than cumulative frequency. So less than cumulative frequencies are plotting in the graph, and locus of all points is called the less than ogive curves. And now go to the next slide where we can see the more than ogive curves. So here more than cumulative frequencies are plotting in the graph, and we are getting the more than ogive curves like this. Clear? I think this is clear to everyone. So now move on the next slide, when both less than cumulative frequency and the more than cumulative frequencies are plotting in the same graph, which is shown like this. Okay, so when we are drawing a line from the intersected point, that is A, from until the horizontal axis, this point or this value is known as median. So I think this is clear how we are getting the median value from the more than and less than ogive curves. So there is a connection, there is a strong connection between ogive curves and median. So now go to the next concept, and that is the concept is definition of graphical representations. So when data are presented in graphs, which is known as the graphical representation of data. So we are going to the next slide. So here we can see the graphical presentation of data is of two types. The first one is time series graph and second one is a frequency line graph. Okay, so now move on the next slide, where we can discuss time series graph and frequency line graph briefly. So now move on the next slide. So learner, we have already discussed the graphical representation of data is of two types. The first one is a time series graph and second one is a frequency line graph, and we have already discussed that thing. So at first we have to know what do you mean by a time series graph. So time series graph refers to the data basically expressed over the different time periods such as weeks, months, years, etc. So we can see in the table the data on population in crore over the different years 1991 to 2021. Okay, so those data are plotting on graph, we get the time series graph. And now move on the next slide, where we can see the graphical representation of the time series graph, and here we measure population in crore in the vertical axis and the different years in the horizontal axis, and this is the time series graph. I think this is clear. So now move on the next type, that is frequency line graph. So what do you mean by a frequency line graph? Frequency line graph is basically a graphical representation of data when we have the discrete frequency distribution. Discrete means a whole number, and these are the frequency according to the marks obtained. Okay, so now move on the next slide, where we can see the graphical representation of the frequency line graph, and we measure a number of students in the vertical axis and the marks obtained in the horizontal axis. Okay, so data are plotting on the graph and then drawing a line from the point up to the horizontal axis, and these line are called the frequency line graph. Okay, so I think it is clear to everyone. So now learner, move on the next slide, where we can see the most important concept, population versus sample. So at first we have to know what do you mean by a population. So population is the totality of the statistical information on a particular character. Okay, so that means the whole thing is called the population or universe. Okay, for example, income of the whole population. Clear? Now go to the sample thing. So sample is a selected part of the population. So for example, we can say the income of the individual, which is the example of the sample. So I think it is clear what is the population and what is the sample. So population is the whole thing and sample is the one part of the whole thing. Clear? So now move on the next slide, and So learner, we are done for the today's session, and the whole chapter, the collection of data, is completed now, which covers a vast area of statistics. We have discussed today the histogram, frequency, polygon, ogive, and time series, frequency line curve, and very important concept of statistics, that is population and sample. So I will come again with a new chapter, that is measures of central tendency. Till then, stay tuned. Please do like, comment, and share, and subscribe my channel. Press the bell button for getting new notification immediately. If you like my session, then do share it with your friends and near ones. Happy learning. Thank you.